Hello, class. Hope you're all doing well. Hopefully, this will be the second to last class that I'm missing, so probably just Monday and Tuesday. So I'm planning to come back Wednesday. Today's lesson is going to be on our next section in the notes. Again, this unit is very helpful for SAT math. It also has a lot of applications, which we'll get into once I get back for class. But for now, what we're going to do is we're going to try to work through the next 4 pages. I'm going to fill in notes, sort of talk about them, and do some of the examples. And then what I want you to do for the class is to go through the examples that I don't do. Work your way through those, and we'll talk about it whenever I get back. Okay. So this section is on how you can say that triangles are similar. So we did something similar for the congruent triangles unit. We went through if you've got angle side angles and they all equal each other, then it's congruent, or all 3 sides equal each other, then it's congruent, things like that. Again, with the congruent ones, each of the sides had to be congruent to the sides of another triangle, and each of the angles had to be congruent. So those were the requirements for congruence, and you can go back to there's a table that sort of said valid or not valid for each of those. We'll review that before we do any quizzes or tests on this, so we know the differences between identifying a triangle as similar or as congruent to another triangle. Okay, there's 3 ways that we can say that triangles are similar. The first one we're going to look at is angle-angle similarity. That means that if 2 of the angles are the same, so B is congruent to E, because they both have the same number of arcs, that means they're the same angle, and A is congruent to D. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. Okay, remember what similar means is that all the angles are the same, it's just dilated. So it's as if we use the scale function in OpenSCAD. So these 2 triangles are similar because this angle equals that one, that angle equals that one. And then the way we would prove this theorem, which we don't have to do, but we know that the 3 angles inside of a triangle always add up to 180 degrees. That means that C has to be the same angle as F. So indeed, all 3 angles are congruent to all 3 angles of the other triangle. So because all the angles are the same, we'd say that it's similar. But you only need 2 angles in a diagram to show that, because you know that the third one also has to be congruent. So that's called angle-angle similarity. If you get 2 angles of one triangle congruent to 2 angles of another triangle, 2 triangles are congruent. Again, for this, we could say once we know 2 angles of a triangle, we can solve for the third. That was something we learned in Unit 5, so solving for missing angles in a triangle. This means that this doesn't necessarily work for other polygons, so you need more than just 2 angles for other polygons. So you need more than just AA for other polygons. All right. Okay, now I'll work through a couple of these, leave a couple for you. So this says 26, that says 64. So this one, it's not immediately apparent. I don't see 2 sets of congruent angles. What I do know how to do is solve for a missing angle. So I know that 90 plus 64 plus whatever this angle is have to equal to 180. So 180 is equal to 90 plus 64 plus, I'll say, K. Looking for K. So that means 90, if we subtract 90 from both sides, that equals 64 plus K, minus 64 on both sides, and I get 26 is equal to K. So that means this is 26 degrees. So this angle is the same as that one's the same as that one. This means that they're similar, and we'd say they're similar because of angle-angle. So I've got 2 angles that match. So 26 matches 26, 90 matches 90. If I were to go through and solve for E, I'd find that E is 64. So those ones work out. All right, let me do this one. So my similarity statement, I should write that as well for this. So for each of these, you should write down a similarity statement, because there's like for this one and this one, there's actually three. Oh no, there's only two triangles, but you do have to show which angles correspond to which ones. So I'm just going to say CDE. CDE. My symbol for similar is this. Okay, so it's not an equal sign, it's just a squiggle. So CDE, and then I've got to name the angles in the same order. So C was 26 degrees, so that'd be K. D was 90 degrees, so that'd be G. And then H was 64, so that'd be E. Yeah. So there's my answer, and it's similar because of angle. For this one, I'll work through this one, so my other angle has to be 46. This one would have to be 43, so not similar for that one. Okay, I want you to try to work through this one, this one, this one, and this one. You're going to have to use some tricks. Again, these are sort of like puzzles. You gotta think through them. Feel free to ask your neighbors about them, but this sort of reasoning is key for their SAT sort of things, or ACT. Just general, like, math standardized tests and later in life. All right. Our next one, are all equilateral triangles similar? I want you to either put yes or no for that. Okay. We'll go on to the next one. So, angle. If we see two angles are congruent, then we know that the triangles are similar. This next way of seeing it is if three of the sides are proportional. Okay. If they were all equal, then we'd say it's congruent. So if the three sides of this triangle equaled the three sides of this one, they would be the same triangle. So we would call that congruent. Again, congruent means equal. If they're proportional, meaning that like this one is 1.5 the size of that, this one's 1.5 the size of that, this one's 1.5 the size of that. Essentially, if we could get this triangle by using scale on this one, then that means that they're similar. Okay, so to fill this in, if all three corresponding side lengths of two triangles are proportional, then the two triangles are similar. Okay, I'm going to work through number 3. Number 4 is very similar, so you're going to work on number 4. Okay, this is nice because it's labeled, it looks like red is the smallest side, then green is next, then blue is after that. You don't have to worry about that, but whenever you're doing the proportions, you want to line it up so that like my shortest side goes with the other shortest side. So first I'll do these two triangles. So I'm going to say 8 over 6, I'll do AB over DE. So 8 over 6, does that equal, let's do 12 over 9. Does that equal 16 over 12? Okay. So 8 over 6 is a fraction that I can simplify. So I can divide both 8 and 6 by 2. So I'll do that here. So that's the same as saying 4 over 3. So 8 over 6 is the same as 4 over 3. I'm wondering, is that equal to 12 over 9? So 12 and 9 are both divisible by 3. I'll divide both of them by 3. Again, I'm just simplifying fractions. All right. How about 16 over 12? Divide both sides by 4. I get 4 over 3 as well. So yes, I'd say similar. So and then my similarity statement would be, I got to make sure I go in the right order for this. So I got to go AB. Let's see. So the first one you don't have to worry about the order with. You just have to make sure when you're writing the second one you get the same order. So what I did is my first length was my shortest one. So AB is the shortest side. So that means DE has to be the first one. I got to worry about like which order, whether it's ED or DE for this. Okay, so I went AB and then BC. So it was shortest side, then middle length side. So AB and then BC. So that means I need shortest side, then middle length side. So that means D, then E, then F. So D, E, F. Okay, I'm going to put the triangle symbol in front of them. I should have done that for my earlier one. That means we're talking about a triangle, not a plane. That would be my congruent statement. Okay, now I'll try the next one. I'm going to try this triangle to this one. Since I know that two of them are similar, that means that if this triangle is similar to this one, it'll also be similar to this one. So I just need to test it with one of these other ones. Okay. So I'll do my same procedure here. I'll try doing these numbers over these numbers. So let's say 6 over 8. Is that equal to, I did 6 over 8, so I should do 9 over 10. Is that equal to 12 over 16? Okay, and then I try to simplify my fractions. This simplifies to 3/4. How about 9, 10? That's already simplified. How about 12 over 16? That'll be 3/4 as well. Okay, so this one we would say not similar. So this is our only similarity statement because this triangle is not similar to these two. So this one, these two are similar. All right. So what I want you to do is I want you to try out number 4. Again, try to figure out, let me just take a quick look at it. So 2 of these are similar to each other. 1 of them is not similar. So figure out which 2 are similar, write a similarity statement. Again, write out your reasoning there. Okay. The last way we know that they're similar is if you have 2 sides that are proportional and an angle that's congruent. So like these 2 triangles, if we knew that this side, when we multiplied it by something equaled this side, and if you multiplied this by the same thing, you get this side. In other words, they're proportional. You know, if we put them in a proportion, they would equal each other. And these 2 angles are congruent, then we can say that the triangles are similar. So that the lengths of 2 sides of one triangle are proportional. Again, in terms of math, this is a proportionality statement. When it's talking about proportionality, it means you can do that and they'll equal each other. And if the included angles, okay, that just means the angle between our 2 sides are congruent, then the 2 triangles are similar. Okay. All right. So here we go. So for this set of questions, what we have to do is we got to set up a proportion that works and then say that 2 angles are congruent. So I'm going to do this for, I'm going to do it for this one, and I'll do it for this one. Okay, I'm going to leave you these 2. So my angles that I can say are congruent is angle R is equal to angle N. Okay, and then for proportionality, it looks like 18 over 24. That's like 3 over 4. And then 21 over 28 is also 3 over 4. So I'd say 18 over 24 is equal to 21 over 18, or over 28. Okay, what I need for the triangle to be congruent is I got to say that in terms of my letters. So I'd say RS over NP is equal to RT over NQ. Okay, so again, saying that this one over this one is equal to this one over this one. I sort of flip these upside down, but what's important is that like the top of my fractions always line up with the same triangle. So the top's from this triangle, bottom's from this triangle, or you do it the other way. So top is from this triangle, bottom's from this triangle. You can't like flip it around. You can't switch it up like that. Okay, so then my similarity statement, I can say, let's say SRT, so triangle SRT is congruent to triangle PNQ. Again, you got to watch out for your order there. Okay, I'm going to do this one. I'm going to do this one right here. Okay, so I've got 2 different triangles here. I've got AEF, which goes AEF, so that triangle there. I also have the larger triangle, so this one here. This is going to be a little trickier, but it's a trick that you'll see in the future, so it's good to know. So A, C, B is my other one. So A to C to B. Those are the 2 triangles I'm dealing with. All right, now in terms of angles, I need to show that one of the angles is shared between those 2 triangles. Again, we had one of the angles was shared, one of the angles was shared, one of the angles was congruent. So A is included in both of these triangles, and it's the same angle as itself. So I can say angle A is congruent to angle A, right? So that already gets us our one angle. Now we have to think about the sides being proportional. So I'm going to say, let me just write down the side lengths here. So AE is equal to 8. AC is equal to 12 because AC equals 8 plus 4, so that's 12. AF is equal to 10, and then AB is equal to 15. Again, I get 15 from 10 plus 5. So this is the length of that bigger triangle. This is the length of that bigger triangle. Okay, so what I need is I need this smaller length right here, which I'll do. See, I don't have a good different colored pen here. This smaller length, I have to show that this length over this length is equal to this length over that length. Okay, so right here is my small triangle, and this is my big triangle. Those are my lengths for them. Okay, so now I set up my proportionality statement. I say 8 over 12, does that equal 10 over 15? Okay, and then I simplify my fractions. All right, so I do 8 over 12, that simplifies to 2 over 3. Is that equal to 2 over 3? Yep, it is. So I would say that these are similar. So I'd say triangle AEF is similar to triangle ACB. Again, I'm being careful of the way that I name my triangles to make sure that I've got the letters in the right order. So A is the angle that they both share. So I started off with that angle that's congruent. And then AE was the side that corresponded to AC. So AE and AC are in the same position. And then AF, or I guess EF and CB are the same. So EF and CB are the same. Yeah, again, that's, if you look at it, you can generally get the right order. It might take a little practice, but we'll practice in class. Okay. And then for this one, let's not worry about number 7 for now, and then we'll look at number 6. I think 6 is a good thing for you to go through and try to do. Okay, so what I want you to do for class then, let me see which ones I've left for you. Again, if you don't get all these done, it's no big problem. We'll return as a whole. I would like you to, if you get stuck, ask each other for advice on learning how to solve these, or if one of you knows how to do it and one of you doesn't, you know, help each other out here. So I want you to go through, I want you to do these 4. I want you to answer 2 as a yes or no question. I want you to do number 4 here, and numbers like these 2 on number 5, and then get through these. That'll probably take a while. It's going to be challenging stuff, but I think that you can go through, and I think you got a good shot at getting a lot of these done. So good luck, and I'll see you on Wednesday.